1, and let's begin. Finding the circumcenter. This is really interesting and something that most people will not know about, but it's a cool exercise to do to really test your understanding of perpendicular bisectors, what happens to intersections, creating slopes, and the different types of lines. So here, what I'm going to do is I'm going to just tell you what a circumcenter is, and then we're going to do an example which is going to be pretty involved to try to find the circumcenter from 3 different points, which basically can construct a triangle. So you see a triangle here which is constructed from 3 points, and this particular triangle that we have here, so from point 1 to point 2, from point 2 to point 3, and from point 1 to point 3, or from point 3 to point 1. So here is our triangle. Now it turns out that if you take the midpoints, and in particular if you take the line segment P1 and P2, and you take the perpendicular bisector, which basically means it is the line that cuts that line segment into a half. So you're going to find a midpoint. So this means that this and this, these are 2 equal, and this point right here is the midpoint. And the perpendicular bisector means that this is at a 90 degree right here. That line that is constructed. Now, if you do that for every single of those lines, so for now I take P1 and P3 and take the perpendicular bisector to that, so that's going to be this line right here, so the one in purple, and then finally you find the perpendicular bisector right here. You will notice that those lines will intersect at a certain point. So it's pretty neat that this point turns out to be called the circumcenter. Now, why is it the center? Well, I drew an actual circle that goes through every single point, and the center of that circle is actually the circumcenter. So if you take a circle which goes through all the points and you want to find its center, you can take 3 points on that circle, and then from those points you can create a triangle with perpendicular bisectors, and then you can find exactly where that center actually is. Now, it's not the only way to find the center, but that's what we have here. Now, from that, so we have that the circumcenter, okay, basically all the points are equidistant to that circumcenter. So point 1, point 2, and point 3 are equidistant from the circumcenter. And that should make sense to you because it is nothing else but simply the radius that goes all the way around. So if I would draw here this line, right, and I go all the way around here, so that is nothing else but just simply the radius which is going around, and it is equidistant to point 1, point 3, point 2. All right, so that is the actual radius that we have, and that's what it says there. So the center of the circle joining the actual 3 points is the circumcenter. Now, if you take a general example, so here is a general, let's say, triangle. It's on the Cartesian plane. So what I have done is I have plotted 3 points on this particular Cartesian plane. So we have 3 particular points, and then what I have done is I've labeled the midpoints of each line segment. Now, finding the midpoint is pretty simple, so you just simply add the 2 points. So for example, I can add this point plus this point and divide it by 2. So notice the x value, which is -2, and then -4, which is going to give you -6. Divide that by 2, you get -3. And you can do that to the y value as well, and you'll find your midpoint. Now, I have done that for every single line segment, so I've found the actual midpoints. Now, what we're going to try to do is we're going to try to find the circumcenter from these particular points. Now, you're going to find something very interesting, because here, when I drew this out, notice that the circumcenter lay right inside of the actual triangle. This is not always the case because it depends where the points are located. If I would take this, I'm going to delete this right here just to kind of clean it up a little bit. If I would take the same circle, but the points would have been something a little bit different. So let's say if the one of the points was here and then one of the points was over here. Now if you created this triangle, you would notice that within this triangle, if you wanted to find the circumcenter, it would still be in the same spot as this other triangle, which is the P1, P2, and P3. So if you would take the perpendicular bisectors of this new triangle that you see here, so let's say P1, I'm going to call this P4, and then P5, you would notice that it would lie again somewhere, okay, within. Now in this case it would be outside of this red triangle that we've done, so it would have been kind of somewhere over here, I guess, that we would have it. Okay, so somewhere here, forget what that center, the circumcenter, would be. All right, so don't think that a circumcenter has to be within the triangle that you're drawing. It can be actually outside. And what that is if you take the perpendicular bisectors of each of the line segments, it is the point where they meet each other. That is the circumcenter, and it can be inside the triangle or it can be outside of the triangle. And we're going to see that within this example, it's going to most likely lie outside of the triangle. So we're going to take a look and see what happens there. All right, so let's take a look. All right, so we have our midpoints. Now we're going to start constructing our actual perpendicular bisectors. Now, if you forgot about the perpendicular bisectors, I'll put up a link up above on how to find them. So I'm going to show you, okay, so here, except I'm going to do it in fast forward kind of motion, and I'm going to find the perpendicular bisectors of each. So what do we need to find a perpendicular bisector? So I'm going to, take that line number 1. All right, so for let's take this line first. So what I would need is, I would need its actual slope. Once I have its slope, then I know that the line which is perpendicular to that slope will be the negative reciprocal of that slope, and it's going to give me the slope of that line. I know the midpoint, so I know the slope. I know the midpoint, which is a point, so I can find exactly what that line is. So I'm going to do that for one of them. So my slope for line number 1, which is m, is equal to, so this particular slope, which is rise over run, I'm going to take 4 minus negative 1 divided by, and now I can divide this up, and this is now my x. So my x is going to be negative 2 minus, and it's going to be negative 4. So notice what we have here. This is 5. And it's going to be over, so negative 2 plus 4, which is going to be 2. So that's my slope. And if I want to find the perpendicular bisector to that, I'm going to take the reciprocal and the negative reciprocal of that. So notice that this is my slope of the perpendicular bisector. So I have the slope. Now, my equation of the line, which is y is equal to negative 2 over 5x plus my y-intercept. My y-intercept I can obtain from the actual point. So this is the point, negative 3 and 3 over 2. That's the point right here that I am looking for. So that's what I want the line to go through. So if I have this, then my equation is going to be, this is negative 3 plus b. Now I can solve this for b. And that's going to be, so negative, so that's going to become positive 6 over 5, 3 over 2. Bring this over to the other side. This is my b. So it's going to be 3 over 2 minus 6 over 5 is equal to b. So finding a common denominator, which is going to be 10 for these. All right, so that's going to be 15. And this is going to be minus, so that's going to be 12. I guess. So that's what we have. 15 minus 12 is 3, so it's going to be 3 over 10. So that's my B. So my entire line in this case, so that particular line, so line number 1, that perpendicular bisector, so that particular line is just simply negative 2 over 5x plus 3 over 10. That's what this would be. And if you look at it, you definitely seem, okay, so what it would be, okay, so if we have the other point, so the was 3 over 10, so it's going to intersect somewhere over there, all right? So this is going to go, so this line, it's going to go something like this, all right? So it's going to head off somewhere right there, maybe. Okay, so that's kind of how it looks like. And this should be, actually this is on the negative side, so it should be a little bit more like that, okay, because it's 3 over 10, not negative 3 over 10. So this is what we have there. And that is, you know, this is the perpendicular bisector of that. So we will now try to construct, okay, the other bisectors, okay, of line number 2 and then line number 3. So I'm going to construct those and I'm going to kind of draw them out so that I can see them. And then I'm going to plot it. I'm going to use Desmos, a tool, which is online, which I highly recommend. So we're going to plot all of those lines and then we're going to see where they intersect. And where they intersect is our circumcenter. All right, so we'll see you in a few moments. All right, so welcome back. So that took quite a while. So I wanted to basically go through all of the different lines. So here are my lines 1, 2, and 3. So these are the perpendicular bisectors. So I've drawn 2 of them. And then the third one, when we draw it, you'll notice that it's going to create the circumcenter, which is going to be outside at the bottom of that triangle. Now what I've also done is to show you visually. So using Desmos, I plotted the 3 lines. So you'll see that on the left. I plotted the 3 points. So the negative 2, 4, 5, 3, negative 4, and negative 1. So I put those into Desmos. So you have them there labeled. And notice that the 3 lines are the perpendicular bisectors. And notice where they meet. So where they actually meet is the circumcenter. So if we would connect these, so I'm going to take this, I'm going to take a screenshot here and so that you can see it out, and I'm going to connect them and put them into our plot there. So let me go back and then add it into our document here. So notice right here, if I blow this up, then if I drew the actual triangle in here, so what I would have is, you know, my triangle would be, you know, so let's say this is kind of how the triangle looked like right there. There it is. And let me just adjust this a little bit. So that's a triangle. Now you have the midpoints of that triangle. So here is, you know, midpoint number 1. You had, so here is the red is the midpoint. Okay, so here is the midpoint of that. And then finally here is your last midpoint right here. And those are the perpendicular bisectors that go off of those. And our actual point, okay, of intersection is somewhere right there. And now how would we find that point? Well, you can take any of these 2 lines and then find the intersecting point. So you can use substitution, you can use elimination method, you can graph it, whatever it is. I'll leave that up to you, but that would be the circumcenter. And now if we would draw a circle which would go across this entire thing, then we would find that the actual circle touches the 3 points, with the center being that actual circumcenter. So if I go back here to decimals, let me blow up, let me zoom in here just to try to see, and where does that actual center is. So there we have it. So it doesn't look like it's a very pretty circumcenter for us. So you can, blow up and make this, even closer there, as close as you want it to go. And I would suggest that you simply take two of the lines and then find what the circumcenter is by elimination or substitution. And that brings us towards the end, or at least of this particular topic. So it's a pretty neat one and forces you to know quite a lot. If you had this on a test or an exam, you would have to do quite a bit of work if someone just gives you 3 points and then says, all right, find the circumcenter that would be made out of a triangle which connects those 3 points. All right. So for any questions, you can put them down in the comments. And definitely not an easy topic, and most teachers will not teach this. This is actually a grade 10 content, which is supposed to be typically taught, but you may not always see it. Thanks for watching. See you in a future video. Bye, everybody.